Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to build from scratch a PDF question answering using ChromaDB and Google Gemini. We are not going to use LangChain in this video. The goal here is to basically do everything from scratch, help you understand each component because LangChain, you know that hey, I use recursive text character splitter, we use loaders, but we probably have never done everything by hand. This video will give you a very good understanding of how to build things from scratch, and then when you go into the LangChain videos you can expand on this knowledge, right? So we are going to build a RAG here. We'll take a PDF as part of this today's code along. We'll take a PDF, we'll take a URL, save the PDF on the disk. Then we'll read the PDF, go through all of the pages, extract text from those pages, and then once we have the extracted text, we'll convert that text into chunks. We'll build our own chunking mechanism here. So we'll not use recursive character text splitter here. We'll basically, or some other text character splitter, we'll build our own text character splitter. So then once the chunks are available, we'll use Google Gemini embeddings and save them to ChromaDB. So we'll convert these chunks into embeddings using Google Gemini embeddings and then save them to to ChromaDB. Next, whatever query the user enters, we'll take that query and do a similarity search on ChromaDB and find the top three most similar results basis whatever chunks we have saved. Now, you can do this for several PDFs. No need to just get stuck with just one PDF. Let's just say if I am doing things on a financial domain, I might want to pick transcripts or annual notes from various competing companies in a domain, and I can ingest all of that into ChromaDB. And then my query could be, hey, how is, let's just say if I was doing some analysis on the content delivery networks, or maybe if I was doing something on the advertising space, my query could be, how is the advertising space looking at generative AI? And then by looking at the top three companies and their conf call transcripts or their annual reports, I can then find the top three most similar results. This could be top five, top three, top 10, whatever you want. And then those will be part of my context. Now, this context will then get added to the question and the prompt, and this prompt will get sent to Gemini, and you will be able to see the output, right? So, once we have built this, this is the entire thing we'll go out and build. I have already completed the video, and the introduction is coming out later. But you will be able to see, we generate this text, this becomes the context, and how we'll build it from scratch. It'll be a fun video. Do watch till the end. If you want, you can watch it at 1.5x speed. The code is available as part of the description in the Colab notebook. Thank you so much. I hope it will be fun. Let's go on. Thank you. Okay, so I'm in my Google Colab, and as part of this question and answer RAG on PDFs, we are going to follow certain steps, like I mentioned, right? So we are going to basically follow these steps. We'll first take a URL of a PDF and save the PDF. Next, we'll load the PDF. We'll convert the PDF into chunks. Now, remember, for this tutorial, I'm not using any loader, splitter, which LangChain offers. We are going to build everything from hand, right? Idea is to understand the concept here. So we'll convert them into chunks. Once they are converted into chunks, we'll use Google Gemini embeddings and we'll use ChromaDB, right? So, and using Gemini embeddings and the PDF chunks that we have, we will now save those chunks in our ChromaDB. If you remember from our ChromaDB tutorial, for creating a collection, you need two basic things. One is you need a name of the ChromaDB collection and you need embedding function. So we're going to use Google Gemini embeddings and we'll give some name and we'll save these chunks. Next, what we'll do is whatever is the user input, that becomes our query, right? So number 4 here becomes our query, and we have information ingested in our ChromaDB already. We'll do a similarity search basis the query that comes in. Behind the scenes, this query will get converted into embeddings. Those embeddings will get, there will be a cosine distance check against all the other embeddings stored in ChromaDB, and nearest neighbors are going to get returned. So we'll get top three most similar results. You can configure how many you want. We'll configure it to top three. that will become our context, right? We'll add context to the prompt. We'll have some prompt which will say, hey, you know what, answer this question basics basis the context, and we'll also give the question. So the question will get added to the prompt, the context will get added to the prompt, we'll send the prompt to Gemini for an answer. Once Gemini responds back, we'll pass that output and we'll show that output, right? So this is a basic code along that we are going to do today. I'm sure you will learn something new. Follow along. If you feel that the speed is slow, watch it at 1.5. There is also chapter information. There is a full collab notebook that is part of the part of the YouTube description. Have a look at it, and if you like it, do comment, share, like, subscribe. Thank you so much. Let's get started. So let's first install all the necessary libraries. For this project, we'll need requests. So because look at the steps that are mentioned here. So we'll need request library. So I'll say pip install request. Then we need some sort of a PDF reader. I'm going to go with PyPDF2. Um, then we need Google Gemini. So we'll have pip install Google hyphen generative AI. We'll also install ChromaDB. So with these, let's just first install these libraries. And once the installation is done, what we'll do is we'll configure Google Generative AI. While the installation is happening in the previous cell, let's quickly write down our configuration for Google Gemini, right? So in order to use Google Gemini, what we do is we'll first, I have all my secrets available here. I need the Google API key. If you don't already have your Google API key for Gemini, you should type Google Gemini API key, and it will take you to the Maker Studio, Maker Suite, sorry, from where you can get aistudio.google.com/app/API key, and you should be able to get your key from here. So if you click on this create API key, it will ask you which project you want the key to be part of, and once you submit, you will get the key, right? So get your key. Once you have your key, come back, store it in the secrets manager, make it available, and then because I have my key stored here, I'll just say from google.colab import user data. This allows you to access the secrets manager, and then Gen AI will first import Google Generative AI. So from Google, or let's just say import Google dot generative AI as Gen AI, and then we'll say Gen AI dot configure. We need to configure the key here, so we'll say Gen AI dot configure API underscore key is equal to user data dot get, and whatever is the name of your key that you have in your secrets manager. Mine is called Google underscore API underscore key, and therefore I am using Google underscore API underscore key. Run this command. This will configure your Google generative AI. Next, what we'll do is I just want to check if my configuration is all right. So there is from for m in Gen AI dot list underscore models. This will list all the models that are there as part of Google Gemini, and we can quickly see what are the various models that are available. So if we just run this, and if the names come up, you know that your key is working fine. So these are the various models. Not all of them can be used for generating content. If you want to just figure out which models are useful for generating content, we can update this line and we can say if generate content in m dot supported underscore generation methods, then only print the name, right? So we just updated the code a little bit, and these are the various generation models, right? So some of them in the previous one you would have seen, some of them were also embedding models that were there. We'll use one of that in this video in a while, right? So now our Google Gemini is configured. We now need to write a method to download the PDF, and for that we'll first import requests, and we'll import OS, and we'll say we're going to create create a method called download underscore PDF, which will take a URL and a save path and download the PDF from the URL and save it in the path specified. Okay, so we are basically now building a function called download PDF, which will download these. What we'll do is we'll say response is equal to request.get URL. This becomes our response, and we'll say response.raise for status. Whatever is the path that was given, when we get the response back, we'll just write the file, right? So this is the simple method that will download our that will take our take a URL and download it from the internet and save it in the local disk. Now the PDF I'm interested in right now is called attention is all you need. This is a PDF I'm most interested in. This is an amazing paper that was released on convolutional neural networks. So I'll take this PDF and I'll say my URL is equal to this. We are going to work with this PDF for now, and my save path is equal to attention is all you need dot pdf. Okay, with this we'll call the method, we'll say download underscore pdf, and we'll pass it the URL and the PDF path. So this becomes, let's just run this. We should see, once this is completed, I should see the PDF here, and I can see the PDF here. So that means my our code has run fine. Our PDF has got downloaded. Next, with the PDF available, the second step that we need to do as part of this is, so the PDF is now available. We need to now load the PDF and convert it into various chunks, right? So chunks are nothing but smaller. And why do you convert things to chunks? Is because, while Gemini has a very long context window, this not every model has that, right? So Gemini Pro 1.5 has a 1 million context window, right? So the tokens it can take is 1 million tokens. But not every model has that. So what you do is you take large corpuses and you convert them into smaller chunks, right? And when you have to pass things from with the prompt, you only pass whatever is relevant. You don't pass the entire PDF, right? You pass that part or those parts of the PDF which are relevant for that question, right? So next what we'll do is we'll come back to our steps, and we have the using request, we have downloaded the PDF interest. We'll now load the PDF and we'll chunk the PDF. So step 2 and 3 is what we are interested in now as far as the code goes, right? So we'll make use of the PyPDF2. So we'll say import or from PyPDF to import PDF reader, right? So we are going to make use of PDF reader, and we'll say write a function called PDF load underscore PDF, which will take a PDF file as file path and extract the text from it using PDF reader. Okay, so this is it has given me some code. I have accepted it for now. I'm just going to read the code and see if it is making sense or not. So it says load PDF, and this is also the reason why I write these comments, because so that if you write these beautiful comments, you are instructing the generative model within Colab or within Visual Studio Code, if you are using GitHub Copilot or any other such model, to understand what is required, right? So I'm saying write a function called load PDF. So load PDF is their file path it takes, and then it says PDF readers PDF reader file path. Okay, this makes sense. Then it is instantiating an empty variable called text, and it is going through. So PDF reader has something called pages, so it is going to go through each page. So if your document has, let's say, attention is all you need, how many PDFs, how many it has 15, so it will go through 15 pages, right? So it has 15 pages, it will go through 15 pages, and after going through each page, it will then extract the text. So whatever is the text, it cannot extract the images, so it will extract all these text, whatever text is written, it will be able to extract that, right? And it will return the text. This code looks okay to me. There is no error handling in it, like, if the file is not found or there is some other exception, those things are not there, but we'll let go of it for now, right? We'll probably come back to it later. PDF underscore text is now load PDF and our save path, right? So whatever was the save path, I'm giving that, right? So this should give us the PDF text. Okay, end of file marker not found. So something is wrong. We'll just quickly see what is wrong. Uh, So, when such errors come, one of the good thing is just go to Stack Overflow and figure out what is wrong, right? And I went through this Stack Overflow entry, and it seems like there is a problem that, some of the PDF files don't have this end of file marker. Now, there are a lot of suggestions like, hey, read the file, maybe, just ignore the last few lines before the end of file marker would have come. And, there are some hacks to avoid this. But one solution that someone mentioned, I'm going to try this. That, one simple solution is open your PDF in another application and then export this and see if it works. So I'm just going to download the PDF from here, and we are going to call it attention is all you need .pdf, and I'm going to basically import this PDF. I'll delete the file from here and see if it works, right? So I'm just going to delete this. It's deleted. I'm now going to import the new file and see if just doing that kind of helped. Like this thread mentions that there are issues with end of file, and while we can actually solve it by adding some more methods and all of that, that's not the goal of this video, so I'm just going to skip that part. I have the new file here, and I'm going to rerun this function and see if it works this time or not, right? It seems it has worked. One way to check is just load, let's say, the first 50 characters and see what comes back. So I'm going to load provided proper attribution is provided and all of that. These are the first, sorry, I'm just going to say everything up to first 500. Let's see what comes back. Providers, Google hereby grants permission and all of that, right? So we probably are getting this right now, right? So seems like the PDF has loaded. We'll now get to the point where our PDF is available, and we now need to do some chunking with it, right? So if you look at the pages in the PDF, or the complete length of the PDF text, length of PDF text, you will see that there are some 39,472 characters. Here is where the PDF pages, those 15 pages, would have got read. Now we have one full big string which we were creating here. We have one big string which has 39,472 characters. Now let's build a recursive text splitter, right? Not exactly the kind you have in LangChain, but we'll make an attempt, right? So we'll say def split text recursively, or let me just write the comment first, right? So build a function called split text recursively, which will take and will basically take the text itself, text which is the original text which needs to be split, the max length of the chunk, and the chunk overlap, to specify how much overlap is allowed between two chunks. Okay, so we'll take this function. It has already given me, we can even say chunk overlap by default is 0. Max length, if you want, we can specify the max length as 1000 by default, so that there are some defaults that the function has. Now what we'll do is we'll have chunks, we'll create a list called chunks, and this is the list that we'll finally return. So we'll say start at the beginning. So start is equal to 0, which means that start at the beginning. And then we'll say text length is equal to len of text, right? So we want to figure out how long is the text provided. Yeah. So Google is telling me that, hey, you know what, I have a GPU runtime, but I'm not using it and all that. You don't need a GPU for this exercise. I think I'm already connected to a T4, so which is okay. Let it be. So now Google has started. Now Collab has started telling me what it thinks should come next, right? So start is less than text length, makes sense. I want to keep incrementing this counter, so it's saying, hey, while start is less than text length, end is start plus max length. So we want to decide where to end this part of the text so it's not too long. So end is start plus max length. If end is greater than text length, that means if we have not yet reached, if end is greater than end is this. Okay, up till this part I will probably accept. Okay, oh sorry, it went away, which is okay. We'll write on our own. End is start plus max length. We are at this point, what we are doing is, we start is 0, we are starting at the beginning. Text length we're figuring out. We want to figure out that, we want to keep going until we have looked at all the text, right? Looked at all the text. End is equal to start plus max length. What this tells me is that, we want to keep going. So end is start plus max length. Then we'll say if end is less than text underscore length, which means if we are not yet at the end of the text, then what do we want to do? If end is less than this, then end is equal to uh, text.rfind, which is recursively find uh, empty point start end, and we'll increment this by 1. We are basically saying that, hey, find the end of the chunk, or end the chunk at an empty space. We don't want to, we don't want to chunk midway, right? Let's say a sentence has some word called drowning, right? I don't want to end at dro, right? I want basically the splitter to take the entire word. That's the goal we want, and therefore we are trying to split on. We are finding the empty space, and we are going to split on that. We are saying end is that. If, let's say, if end is less than equal to start, then we are saying end is equal to start plus max length. What we are saying is, if there's no split, if there's no space, then just end. If there is no space, then just split at the max length, right? So if it doesn't find a space, then we have to honor the max length has to be honored, right? So that's what we are doing. And then with this, what will happen is, our segment is equal to, or sorry, our calling it the chunk, our chunk is equal to text of start, go from start till the end, and do a strip, right? So take the text from start to end and remove any extra spaces that we have, right? So that's what our goal is. Take the text from start to end and remove extra spaces, right? So this is probably the most longest function we'll write in this tutorial. uh, and what we are trying to do is, we're just trying to build the splitter here, right? So if chunk, if it found a chunk, then we'll say chunk dot append chunks, chunks dot append chunk, sorry, chunks dot append chunk. uh, if we found a chunk, we'll just append this chunk to this list. That's what we are trying to do here, right? So and then what we'll do is, we'll say start is equal to end minus chunk underscore overlap, right? So move the start forward. We are basically moving the start position forward minus any overlaps that we want. Minus any overlaps, right? So this is what we did now. Once this is done, we'll just say if start is greater than equal to text underscore length, which will mean that we have reached the end of the text, then we'll just break and we'll return the chunks, right? So this is the method. We now have our split text method ready. We can quickly test it. The way to do it is we'll say chunks is equal to split text recursively, and we can pass in the PDF text that we got earlier. So we'll pass the PDF underscore text. We can say max length for our case can be 2000 and max overlap can be 200, right? Sorry, chunk overlap, not max overlap. So this will be chunk overlap. I hope this is the name. Yeah, chunk overlap. We'll just run this. We should get chunks back. We'll quickly look at the length of these chunks. So we have 23 chunks now, right? So we have 23 chunks. If you look at it, we had 39,472. If there was no chunk overlap, then 39,000 divided by 200, 2,000, roughly 20 chunks we would have got. But we'll not go with zero chunk overlap because that means sometimes the context gets lost. That is not what we want. So we'll run this again, and now we get back 23 chunks, right? So from 20 chunks for 39,000 characters, each being 2,000, each chunk being 2,000 characters, we are getting 23,000 chunks. If you want, we can just quickly see how the first chunk looks like. So chunks of zero, um, let's see. So this is how it looks like. This is the first chunk that the model has given us, right? Our function has given us, right? So now with the chunks being there, what we now need to do is we'll get to the part where our chunks are available. We are at this point where our chunks are now available, and we now need to use ChromaDB and Google Gemini embeddings to store these, right? So we are going to make use of the Google Gemini embeddings and ChromaDB to store those chunks into ChromaDB, right? So let's get started with that. We'll quickly import ChromaDB. We have installed ChromaDB earlier, and ChromaDB has this embedding functions. If you have not seen my ChromaDB tutorial earlier, ChromaDB embeddings, if you go to ChromaDB embeddings and we come to the guides, maybe not the guides, okay, there was something guides, okay, and we come to Google generative AI, you can see there is an embeddings function, right? So we're going to make use of the embeddings function here. So we're going to import from chromadb.utils.embedding function as embedding functions. And now we are going to create, let's just go back to this. We'll say Google embedding function is this, and we'll just copy this thing, come back here. API key is my API key we had already imported here. We had when we were setting up, we'll just pass the same thing here. API key is nothing but user data.get Google API key. And next, what we need to do is we need to create a ChromaDB client, right? So our embeddings function is ready. We now need to create a client, right? So we'll say client is equal to ChromaDB dot persistent client. I have covered a lot of this in extreme detail in my other video. There's a playlist called ChromaDB playlist. You should go through it, and you will see that all of this has been covered there. Right, so we are saying we'll create a persistent client. ChromaDB by default is an ephemeral database. So, but you can create a persistent client where you can write things on disk. I'm writing again. While I'm writing on an ephemeral instance. This T4 instance will go away the moment I close this. So, but if this was a machine, like a more permanent machine, or I could have given the path which is more permanent, right? So this is how you create your ChromaDB persistent client. Next, we need to create a collection, and we'll say collection is client dot get create connection, and we'll name the collection as name is equal to pdf underscore rag, and embedding function is Google EF, right? So our Google EF, this is our embedding function. This is where we are using Google Generative AI embedding function, as you can see here in the documentation. I'm using the same thing, and with this now, our with this our collection will get created. We can even add items to the collection by saying for I comma d in enumerate uh, chunks, we'll say collection dot add documents is equal to d, and IDs is equal to str of I, right? So it takes a string, and I'm just going to loop through these chunks and keep adding them, right? I can even do a batch update. We could have just given the entire chunk and created an IDs and a list of IDs and given it as a chunk as a one shot instead of looping. But because we only have 23 segments, this won't be a problem. Otherwise, we could have given this entire thing as chunks, and we could have created a list of IDs and used that, right? So it would have been the same thing. uh, yeah, so now this is done. We can quickly see collection.count, which will tell us that there are 23 objects. Yeah, so with this now our ingestion is done. We are done with the chunks. Now we need to find a query and do a similarity search and pick the top most three similar results, right? So that's what we are going to build now. So our chunks are saved. Now let's say we want to find def find relevant context. So we'll say whatever is the relevant context, we are going to pass these things. The query is the question that the user posts. DB is the DB, it's the collection. And how many results do we want? I'll say by default we want just three. And we'll say results is equal to db dot query, query underscore text is equal to query. You pass the query and you say n results, n underscore results is equal to n underscore results, right? So this should be results. Results is equal to db dot query, query text, query n results. Yes, and we'll return the results, right? So we have just created a method to find relevant context from the database, right? Now what we'll do is, because if you look at these chunks, right, all of these chunks have we want to do some sort of an escaping on it, right? So that there is um, these chunks, or let's leave it, we probably don't need it. We can leave it for now. Yeah, so let's quickly see what kind of results come back. So we'll say find relevant context, and we'll pass it. The query is, let's say, role of encoders, and we'll pass it collection. That's the name of our collection, and that's not the name of our collection. That's the collection instance, and we'll say three, right? So we don't even need to basically pass this. Find relevant context. I had run this. Why am I getting? Okay, so now let's see what kind of results come back. Still doing something. Sometimes, because these are shared instances, this can take a little longer. Ideally, for this size database, it should not have taken this long. And now, if we look at results, uh, you can see that the results have various things, right? So we don't want all of these. We don't want the distances. Embeddings is anyways not returned. We are mostly interested only in the documents, right? So but if you look at this list, right, there are a lot of things. There are a lot of things in this, and it's a list of lists. So we maybe want to create one list out of this. So we want documents. So if you look at results of documents, you will see that it's a list of lists. You see this is a list of lists. If we just look at the first list within this, because we are returning three different items, this should be a list of three, right? So if you look at the length of this, because we are returning three results, this length has to be three, right? So what we will do is we will go through each list and we'll keep adding the list contents and make it one big passage, right? So that's what my goal here is, so that the model has enough context, right? So we'll create a function called def build escaped context, and we'll give it the context. Next we'll say escaped context is equal to empty string, and we'll say for char in context, if char is this escaped context, no, I don't want this. This is not what my goal is. I want to basically loop through each list. So we'll say for item in context, we'll say escaped context is escaped context plus item plus two lines escapes. Yeah, and then we'll return. Yeah, this is what I want, right? So this is going to give me one big list, one big passage where everything will now get added, right? So as one variable. Next we'll say escaped context is equal to build escaped context, and we'll pass it the context, right? So this will give me the escaped context. And now, okay, something is wrong. Context is not defined. Okay, we called it results, we did not call it context. We should have called it context, right? So, and we should have here, when we are returning results, maybe we'll just return documents instead of the entire result, right? So we should get back, must be not string. Okay, what happened? Ah, sorry. Now that the context is documents, it's no more a, it's a list of documents now. And we'll run this again. We'll run this also again. Can only concatenate list, not str to list. Okay, what happened? Escaped context for item in context. Uh, can only concatenate list, not str. Okay, so because it's a list, what we need to do is maybe where I'm saying return documents, I'll also say return just the first document, right? So it's a list of lists. So just return me the first list, which will have all the other lists, right? Um, so you will see here when I do a len on context now, I should get three, right? So now it's no more a list of lists, it's just a list, right? And now if we run len on context, should again be three. Now if we run, I hope we should be able to get the results. Yeah. And let's print escaped context. When we print escaped context this time, you can see that there is this is one big context that we now want to provide to the model, to the llm. So we are at this point here where we have done some similarity search, we have got back the top three, we have the context with us. Now I want to add the context to the prompt and the question to the prompt and send it to Gemini. So we are probably at the last 5 minutes of this tutorial now, right? So what are we going to do now? We are going to say, hey, let's create a function, and I'll quickly start writing and then build the function in the interest of time. So we'll say def create prompt for Gemini. Um, we'll pass in the query and we'll pass in the context. And next what we'll do, we have the function ready. What we are saying is that the prompt is, you are a helpful agent that answers questions using text from the context below. Both the question and context is shared with you, and you should answer the question basis the context and not hallucinate. If the context does not have enough information for you, maybe let's just does not inform about the absence of as part of your answer, we'll be sending the question, we are sending the context, right? And we are asking for the answer, right? Maybe what we can do is we can first send the question, and we can first send the context, and then we can send the question, and then we can ask for an answer. Yeah, so this becomes our prompt. Now what we'll do is we'll say we want one more method, which is generate answer from Gemini. We are going to write that method def generate answer from Gemini, and it will take the prompt, and we'll quickly, at this point, we need to specify the model. So we are going to use Gemini 1.5 Pro latest. You can use any of these models that we listed earlier. When we were starting out, we listed these models. You can use any of them. Vision models are for your images and videos. I'm using the latest model, 1.5 Pro latest. This is a multimodal model, so it can take an image as well. And we are saying model dot generate content basis the prompt, and it should return the result, right? So now let's just call our this method, and we are going to say prompt is create prompt for a Gemini, role of encoders, and context is escaped context, right, that we created earlier. So earlier we created this context which was escaped context, and what we can even do is this method build escaped context can in turn, once we find the relevant context, instead of returning the results, we can actually call build escaped context and then return the escaped context. That way it will be, I think it will be a better one. So instead of returning, at this point we'll just call build escaped context, and we'll pass it the results document 0. um, this way, once this is returned, we'll say return escaped, and we'll say this is my escaped context, and we'll return the escaped context. Yeah, so I'm doing, instead of calling two different methods within, we'll first find the relevant context. Once the context is found, we'll build an escaped context from there itself. That way we don't have to build several method calls, right? We can just get done with one method call. So now I have a context which is 4021 characters. I don't need this anymore. I can just print the context. If I want, I can print context and see how the context looks like. And this is how my context looks like. We'll come down, and instead of escaped context, I'll just pass context here now. Yeah, so, and just let's just see what comes back, right? So prompt is create prompt is done, uh, and I can print the prompt. Next, once the prompt is ready, we need to call our generate answer. So this is my prompt. You are a helpful agent that answers question. Context is this. This is all the context, and this is my question, and this is the answer I want from the model. Now, what we need to do is we need to send this. We need to say answer is equal to, and we need to pass the prompt. And once the prompt returns the answer back, I can quickly look at the answer. You will see that it has various other attributes. What we want is basically the text, so I'll just say print answer dot text. And let's see what comes back. The provided text describes the structure of encoder and decoder in a sequence transduction model, but it does not explicitly contain the role of explain the role of encoders. Right. So you see, this way you can quickly build. We went from scratch. We downloaded the PDF. We built code to download the PDF. We built code to build chunks. Using LangChain, you could have done a recursive character text splitter. We went with building our own chunks. We saved them using Google Gemini embeddings into ChromaDB. Then we took a query, found some similarity, picked out the top three most similar results. We added that to the context and the question, and we then sent it to Gemini, and we parsed the output, right? So we did all of this end to end without any library, and I hope you learned something new in the process. If you like the video, do comment, subscribe, like. Share your feedback, and it'll be very useful. Thank you so much.